Graphing linear and absolute value inequalities with two variables. Let's talk about some key vocabulary. A linear inequality in two variables is when an inequality can be written in the form ax plus by less than c, less than or equal to c, greater than c, or greater than or equal to c. So that's standard form of the linear equation or inequality. A solution to a linear inequality is an ordered pair that forms a true inequality when the x and y values are substituted into the inequality. The graph of a linear inequality in two variables is the set of all points in a coordinate plane that represent solutions. So there's going to be multiple solutions. So you're going to see that. So it's a set of all points. And lastly, we have a half plane. A half plane is two regions of a coordinate plane that are separated by the boundary line of the inequality. When you're graphing linear inequalities, first step is graph the boundary line. You'll use a dashed line if it's less than or greater than. Or you'll use a solid line if it's less than or equal to, greater than or equal to. So similar to how we did the one variable inequalities, when we had an open dot or a closed dot, it's the same idea. It'll be dashed, represents kind of openness, whereas solid represents the equal bar. Step two, you're going to pick a test point, not on the boundary line. Determine if it's a solution. If it is a solution, you shade the half plane that contains the point. Otherwise, you shade the other side. And there is a shortcut, but the shortcut may only be used if it's written in slope-intercept form, not standard form. Slope-intercept form is y equals mx plus b. You should remember that from algebra. If it's written in this format, then you can use the shortcut, and only then. So basically what it says is, if less than or equal to, shade below. If greater than or equal to, shade above. So if it's less than, below. If it's greater than, above. So let's practice. We're going to graph x, 3x minus 2y less than negative 6. It's written in standard form. For those who don't recall, standard form is ax plus by equals c. So it's not in slope-intercept form. To put it into slope-intercept form, we have to solve for y. We have to get y by itself. So the first thing you would do is subtract 3x on both sides. That would leave me with a negative 2y less than negative 3x minus 6. So when you move the 3x, it doesn't affect the 6 that was there, but you show that it's on the other side. Next thing is we have to divide all parts by negative 2. And remember, when you're dividing by or multiplying by a negative, the inequality sign changes. So this sign flips the other direction because I divided everything by -2. So the end result would say y is greater than, negative over negative is a positive, so 3 over 2x. Again, negative over negative is positive, so that's a positive 3. So this is what the equation would look like in slope-intercept form. So when it's in slope-intercept form, again, remember from algebra, that's y equals mx plus b. So when it's aligned, we know that m is 3 over 2. That's our slope. We know that b is equal to 3. That's our y-intercept. So now we can graph our line knowing that information. So we'll plot our y-intercept, which is right here on the y-axis at +3. Then we'll use the slope, which is rise. So rise up, 1, 2, 3, overrun, 1, 2, and plot another dot. So all we need is 2 dots. So the first one was 0, 3. The second one is 2 and 6. Now you draw a straight line through both dots. And, oops, I'm sorry. Is it supposed to be a dashed line or a solid line? It's supposed to be a solid line. So, dash. It's supposed to be a dash line because that equal to bar is not present. So let me change it to dash line. Okay. And it's a line that continues on forever in all directions because lines are unstoppable. So let's add our arrows. Now we're going to pick a test point. I recommend using 0, 0 as long as it's not on the line. And as you can see, 0, 0 is not on our line. Hold on, my line shifted over. So let's fix it. There we go. All right. So 0, 0 is not on our boundary line. So that's going to be our test point. And you probably want to write down your test point. Again, use 0, 0 all the time, as long as it's not on the line. So we're going to substitute 0, 0 into the original equation. Just in case we made an error, we want to use the original equation. So it's 3 times 0 minus 2 times 0, and we're testing to see that it's less than -6. 3 times 0 is 0. 2 times 0 is 0. 0 minus 0 is 0. Is 0 less than -6? No. So that's false. So since it is false, that means we shade the side that doesn't contain 0, 0. So we shade this side. If it was true, we would shade the side that did contain 0, 0. So that's how you graph a linear inequality in two variables. If you want to take a look at it on the calculator, I'll show you what it looks like. So you have to have it in slope-intercept form first. And you got to change it from an equal sign to a greater than sign. So I can't remember how we did that. Nope. Where's my equal sign? Sorry, guys. I don't recall at the moment how to change it to equal sign, but I can show you in class later. I apologize. It's not seeming to do what I want it to do. At the moment. I'm just gonna try one more thing. Well, I found them, but will it work in this feature? Let's see. No, it doesn't. All right, so let me play with the calculator a little more, and I'll demonstrate that in class. But that's how you graph it by hand. Please work on this one on your own. So now let's talk about the absolute value inequality in two variables. When you're graphing the absolute value inequality in two variables, it's similar to graphing a linear inequality. First, you graph the absolute value equation. Then you determine whether the boundary is dashed or solid and which region should be shaded. Again, you're going to use a test point, and depending on if it's equal to or not, determines if it's a solid or dashed. So what I highly recommend doing is putting it into standard form. I'm sorry. You want to get it into the format that looks similar to the parent function. The parent function was y equals absolute value of x. So, sorry, we want to solve for y. To do that, on example 3, we're going to have to move this whole absolute value to the other side. So in order to move this entire thing to the other side, we're going to have to make it negative. So it would look like this: 2y less than or equal to negative absolute value of x plus 1. And then we have to divide by 2 everything. So y is less than or equal to negative absolute value of x plus 1 all over 2. Now, in order to graph the line, I highly recommend creating a table. You need at least 3 points. The 3 x values I highly recommend using are -1, 0, and 1. And then just plug them in. So for example, it'd be y is equal to negative absolute value of -1 plus 1 over 2. And if you calculate that with a calculator, you would end up with a -1 plus 1, so that's 0. So 0 over 2, which is 0. For the second one, it's negative absolute value of 0 plus 1 over 2. So that would give me a 1, so a -1/2. And I'm going fast through these calculations because a calculator can't answer these questions. So use your calculator. And if I want to use 1, so that's negative absolute value of 1 plus 1 over 2. 1 plus 1 is 2. So that's a negative 2 over 2, which is a negative 1. So we plot those points. Negative 1, 0. It's located on the x-axis on the left-hand side. Right here, that's negative 1, 0. 0, negative half is halfway between 1 and 0. And then 1, 1 is up here. Oh, I'm sorry. 1 negative, it's a negative 1. 1 negative 1. So it's down here. Something's not right. Something's not right at all. Negative 1 plus 1 is 0. 0 divided by 2 is 0. 0 plus 1 is 1. It's a negative 1/2. True. Negative, that's 1 plus 1 is 2. Negative 2 over 2 is negative 1. Let's graph this in our calculator. I'm not understanding what just happened. So that would be negative alpha y equals 1 for my fraction. So I want the absolute value, so math num1 of x plus 1 and then over 2 and graph. It wasn't doing what I wanted it to do, but when I hit second table, I see 0 negative half, 1 negative 1, and negative 1 0. Yep, I see those points, but they didn't behave the way I was intending. Sorry, guys. So that's how the graph would appear. Since it is an equal to bar, we're going to make it a dashed line. So it might be helpful to have a graphing calculator nearby to graph this properly. So you get some great points to use on your plot instead of just drawing random lines. And then connect it. Okay. And it's continually moving downwards. Now let's pick a test point. And again, when you pick a test point, go back to the original equation. So I'm going to use 0, 0 because it's not on my line. Or my boundary. So I'm going to take the absolute value of 0 plus 1 plus 2 times 0 and compare it with 0. So the absolute value of 0 plus 1 is 1. So the absolute value of 1 is 1. plus 2 times 0 is 0, less than or equal to 0. So 1 plus 0 is 1. Is 1 less than or equal to 0? No, that's false. So we'll shade below. We'll shade everything beneath it because 0, 0 is not below the graph. It's above the V. So that's why we're shading downwards. Here's 0, 0. There's my test point. So since it was false, we shade everything below. And this concludes your notes. Good luck. Do the rest of the examples on your own.